Hi, good morning everyone. This is Kumar. Welcome to this channel. Today, I would like to explain about graphs. In this graph, present the terminology of the graph. First of all, what is graph? The graph is a non-linear data structure consisting of nodes and edges. The nodes are sometimes also referred to as vertices, and the edges are lines or arcs that connect any two nodes in the graph. The edges are connected to the vertices. That is also called in a lines. The vertices or vertex is representing for the each node. Okay. Generally, a graph G is represented as G equal to V comma E, the general representation, where V is set of vertices and E is set of edges. Okay. For example, the A, B, C, D, E in this graph is representing for G equal to V comma. In this, V is a set of vertices. The vertices means B, A, B, C, D, E. That is representing for V equal to set of A, B, C, D, E. And the E is set of edges. That means equal to set of AB, that is one edge, AC, another edge, CD, another edge, BD, another edge, BE, another edge, and DE for another edge. These are the edges and these are the vertices. In general, the graph terminology vertex, the vertex or vertices. An individual data element of a graph is called a vertex. Generally, the individual data elements is called a vertex. The vertex is also known as a node. Sometimes it is also called a node. Vertex is generally represented using labeled circle. The general is representing for the circle. In the below example, graph A, B, C, D, E are vertices. Next, edge. A link connecting two vertices is known as the edge. It means a link between two vertices. A arc is another name of edge. Sometimes it is also called an arc. An edge is represented as first vertex and second vertex. For example, A, B is a first and it is in a second. For example, in the above graph, the link between the vertices A and B is represented as AB. In the below example graph, there is 7 edges, that is AB, AC, AD, CD, BD, DE and BD. Okay, these are the edges. And there are mainly three types of edges. Generally, three types of edges. The first one is directed edge. The first one is directed edge. Another one is undirected edge and weighted edge. So the generally graph is representing for three types: directed, undirected, and weighted edges. First, directed edges. A directed edge is a unidirectional edge. It is represented using arrow pointing. from source to destination. A pointing to B. It indicates that A is source and B is the destination, like this. If there is a directed edge between vertices A and B, then edge A, B is not equal to edge B, A, because of the B is not directed to A. So the A directed to B, it means AB are not equal to BA. Okay, is that clear? Undirected edges. An undirected edge is bidirectional edge. If there is an undirected edge between vertices A and B, then edge A, B is equal to B, A. It means the A to B and the same way B to A. That is called a bidirectional. The unidirectional is representing only for one way. Next one is weighted edge. A weighted edge is an edge with cost on it. It can be both directed and undirected. The generally weighted edge is representing for the both directed edges and undirected edges. The cost that means, for example, the 1 point to 1 point that travels the edge weight, for example, 5 kilometers. That is the weight of the edge. In general, the graphs are very useful to representing for map pointing. Now the Google Maps are representing using the graphs only. Okay. Then directed graph. A graph with all directed edges is called a directed graph. It means all the edges is representing only for the directed graph. It means the pointing symbol, that is the directed graph. The undirected graph. A graph with all undirected edges is called as a undirected graph. It means all the edges only representing only this way. This is called an undirected. The another one is mixed graph. A graph with directed and undirected edges is called a mixed graph. It means the some edges are representing directed and some edges are representing directed. In this type of representing the any graph, that is called a mixed graph. Endpoint or end vertices. The two vertices joined by an edge are called the end vertices or endpoint of the edge. It means A and B, the A and B, the B is an endpoint. Okay. The next one, origin. In a directed edge, the vertex from which the edge emanates is called as the origin or source of the edge. It means, for example, choose A and B. The A is a origin or source. The next one is the destination. In a directed edge, the vertex at which the edge ends is called as the destination of the edge. It means A, B. The E2 is the edge. The destination is the B, the adjacent. The two vertices are said to be adjacent to each other if there is an edge that joins those vertices. In other words, if there is an edge between vertices A and B, then both A and B are the side to be adjacent to each other. For example, the A adjacent vertices are B, C, D. For example, the C adjacent vertices are A and B only. For example, D adjacent vertices C, A and B, E. And B adjacent vertices A, D, E. The adjacent vertices means the A, the one vertex is connected to the nearest vertex, the incident. An edge is said to be incident on a vertex if the vertex is in one of the endpoint of the edge. Outgoing edge. Outgoing edge, it means the A outgoing edges E1, E3 and E2. For example, C outgoing edges only one, that is E5 only. For example, B outgoing edge only E4 because of E1, B outgoing edges E4 and E7. Okay, in degree. For a given vertex V, the total number of incoming edges is said to be in degree of the vertex. The total number of incoming edges. For example, the A in degree 0 because of all are outgoing edges only. For example, C in degree is 1 because of is a 1 edge for incoming. For example, D in degree 3 because of B, A and C are incoming edges and out degree. For a given vertex V, the total number of outgoing edges is said to be out degree of the vertex. For example, E out degree 3 because of A to B, A to D and A to C. And C out degree only 1, that is C to D. The A to C is in a degree. In this way, to count the out degree and in degree. The next one is degree. A vertex V, the total number of edges connected is said to be degree of the vertex. The previous already discussed. And then another one, the self loop. In directed or undirected edge is self loop if both of its endpoints are same, that is the source equal to destination. It means the B is a self loop because of the B is an outgoing edge and incoming edge also. That type of vertex is called a self loop. Path. Path represents a sequence of edges between two vertices. It means the A to E path, A to B and B to E. It means A to B and B to E. That is the path. For example, A to D, there are so many paths. That is means A to B and B to D and direct A to D and A to C and C to D. In this way, the path is calculated. Clear?